Hello everyone, welcome back to ANR Academy. This is Nepaledi sir. Today I am here with you to discuss the proof of Menelaus Theorem. See the statement. If a transversal cuts the sides BC, CA, AB of triangle ABC at capital X, capital Y, capital Z respectively, then BX by XC multiplied by CY by YA multiplied by AZ by ZB, that should be equal to negative unity. This is the statement. In triangle ABC, three sides BC, CA, AB, and there is a transversal that cuts the three sides at capital X, capital Y, capital Z is given. See this figure. This is the triangle ABC and this is transversal line. It cuts the sides BC at X. Next, given that in the question BC at X, CA at Y. See here in the figure CA at Y, next AB at Z. Now our aim is to find the ratio Bx by Xc, next Cy by Ya, Az by Zb. Finally, we have to prove that this is -1, that is negative unity. To prove Menelaus theorem result, what I am doing, observe. Let us drop perpendiculars from the three vertices capital A, capital B and capital C with respect to the transversal line. What I am saying, you have to drop perpendiculars from vertices to transversal. See here, from vertex C to the transversal, I am going to drop a perpendicular here. It is of 90 degrees. Next, from vertex A to the transversal, one more perpendicular I am going to drop. Yes, this is another perpendicular. Next, from vertex capital B with respect to the transversal, another perpendicular I am going to drop. This one. Assume that this is of height h1 and this is of height h2 and this is of height h3. And foot of the perpendiculars, suppose that P, Q, R respectively. Assume this is P and this is Q and this is R. After dropping perpendiculars from three vertices to the transversal, now let us observe here the two triangles BQX, CRX, these two are similar. What I am saying, from figure it is very clear that first the triangle BQX I am writing, then CRX. Triangle BQX, it is similar to triangle CRX. Why? Because here angle Q 90 degrees, here angle R 90 degrees and one more common angle at X. So by AA similarity, these two triangles are similar. Therefore, when they are similar, their corresponding ratios are proportionate. So that I can write from this I am going to write the proportionate ratios. Here I am writing Bx by Xc. Let us see in the statement, our requirement is Bx by Xc. So Bx by Xc. The direction here it is opposite, remember. B to X, then X to C, reverse direction. Yes, this is of H2 and this is in this direction H3. Their corresponding ratios are proportionate, so that here you have to write H2 divided by H3. Due to opposite direction, I am going to write a negative sign. This is result 1. Here the two triangles are similar, but the direction of Bx and Xc, that is opposite. So it is of opposite direction. Due to that reason, I am going to write the ratio negative H2 by H3. And also observe, next, these two triangles are similar, that is APY CRY. Why? Because here vertically opposite angles are equal, and here you have 90 degrees and here it is of 90 degrees. Again by AA similarity, vertically opposite angles as well as 90 degrees. Two angles are equal. So by again angle similarity, I can write triangle APY, which is similar to triangle CPY. Yes, when the two triangles are similar triangles, then their corresponding sides ratio is proportionate, so that I can write AY by YC. Here you need CY by YA, so direction C to Y first and then Y to A I am writing. Yes, C to Y and then Y to A. C to Y, that is opposite to 90 degrees. So here opposite to 90, what you have in this figure, opposite to 90, no need. Here the relation between H1 and H3, yes, CY from smaller triangle, so height H3 I am going to write here. Next, AY, that is from larger triangle, so that here I am going to write H1. This is result 2. Observe here C to Y and then Y to A you have. Along the same direction we are going to move, so that without negative sign you will get H3 by H1. Also, there are similar triangles. Let us observe these two. This is vertically opposite angle. These two angles are equal, and here it is of 90 and here it is of 90. So these two also similar triangles by AA similarity. What are the triangles here? BQP, first one. Triangle BQP, which is similar to triangle BQZ, it is, right? BQZ, which is similar to APZ. Triangle APZ. Yes, now their corresponding sides ratio proportionate, so that I am writing AZ by ZB. A to Z, then Z to B. The direction is same, so that the ratio what we get H1 by H2. Here it is of h1 divided by h2. Third result. A to Z, Z to B, same direction, so that you have to write positive ratio. Now from 1, 2 and 3. Product of all these bx by xc multiplied by cy by ya multiplied by az by zb, that is equal to minus h2 by h3 multiplied by h3 by h1 multiplied by h1 by h2. h1, h2, h3, product of the terms in the numerator. In the denominator h1, h2, h3, product of the terms. Same quantities gets cancelled. Finally, we get minus 1. Therefore, I can write bx by xc, cy by ya, az by zb. That is clearly negative unity. This is about the proof of Menelaus theorem. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.